Hello, everyone. Myself, I am Sujit, Assistant Professor of Chemistry, Pioneer College, Pioneer. So, in this class, I shall discuss different methods and different rules employed in the nomenclature of heterocyclic compounds. So, before getting into the nomenclature of heterocyclic compounds, you should know why the heterocyclic compounds are very important in our studies. So normally heterocyclic compounds contain carbon. Apart from carbon, it contains some of the heteroatoms like oxygen, sulfur, nitrogen, etc. So of course we know that most of the antibiotics or alkaloids, some of the amino acids, vitamins, hemoglobin, uh, hormones, dyes, drugs, etc. All these contains heterocyclic compounds. Okay? So it's a kind of inevitable kind of molecules in our chemistry, I can say. So coming to the nomenclature, we should there are different types of heterocyclic compounds. So we should systematically name each and every compounds. So nomenclature of heterocycles contains different types of methods. One is a simple one, that is a replacement nomenclature. There is a systematic nomenclature system by Hantzsch and Widman, and nomenclature for the fused and bridged heterocycles. So that's what I told you in the case of nomenclature. Uh, so some special names are given for the individual ring system, and some cases the tribal name and nomenclature is being used. Okay, the systematic nomenclature introduced by Hantzsch and Widman for single 3 to 10 member ring. It is designed so that one can deduce the uh, structure of the compound from its name. Then we shall discuss the replacement nomenclature, different methods employed in the fused nomenclature system, and finally the nomenclature of the bridged heterocycles. So recently IUPAC has made some of the efforts in systematizing the nomenclature for the heterocyclic compounds. Okay? So if you take a single compound, 3-membered or 5-membered, 4, 5, 6, etc. up to 10 membered heterocycle, you can see that the name is divided into two parts. Okay, there can be a stem and there can be uh, prefix and suffix. So the name I can write here the prefix. Okay, so actually the prefix gives that it is divided into two things. It is prefix and suffix or stem. Okay, so prefix actually gives the idea of the different type, what type of heteroatom is present in the heterocyclic compound, and the stem or the name ending suffix give the size of the ring. So I told you, apart from carbon, there are different heteroatoms are present in the heterocyclic compound. So for oxygen, the word is used is oxa. Okay, for oxygen, the word is used is oxa, and for nitrogen, it is aza. It is oxa. It is aza. Okay, and for sulfur, it is thia. Selenium, it is selena. It is selena, and for tellurium, it is tellura. And for phosphorus it is phosphor. Arsenic it is arsa. Silicon it is sila. Germanium it is germa, like that. Okay, so these are the prefix used in a heterocyclic compound. So actually the nomenclature will be like this one. So it is a combination of prefix. The nomenclature is the combination of prefix and suffix or stem. So this is the way of naming a heterocyclic compound. Okay. So coming to the next part, that is the suffix. Okay, that is the name ending or the stem. I told you the suffix gives an idea regarding the size and the unsaturation of the compound. Okay, if the ring size is 3, okay, I have made a table for the suffix for unsaturated and for unsaturated compounds and for saturated compounds. Again, that is a further segmentized into uh, with nitrogen compound with nitrogen and unsaturated compound without nitrogen. Similarly, saturated compound with nitrogen and without nitrogen. The ring size is 3. Okay, you can remember try 3. You can take the IR Okay, so the name for the unsaturated compound with nitrogen is irine. Okay, without nitrogen is irene, and for the saturated compound with nitrogen is iridine, and without nitrogen is ethane. You can find IR, okay, from the try. You can find IR in every cases, IR. And for tetra, four membered, you can remember tetra. Okay, so you can take this ET to remember. You can take the ET. So for four membered heterocyclic compound, the name ending will be EAT, and without nitrogen unsaturated component is EAT. And for saturated analog, it will be etidine, and for other heteroatoms without other than nitrogen, it will be ethane. And for 5, okay, the name ending will be always OLE. Okay, and for 5 membered, the name ending is OLE, ol, triazole, oxidizole, etc. Without nitrogen also OLE. And for saturated, it is olidine. You can always find that in every case it is dine. Dine is repeated, dine, and here one, olane, it is olane. Okay, always you can find that ane is being repeated in this case. Okay, and for 6 member like triazine, 6 member, it is unsaturated with nitrogen is ine, without nitrogen is in, and for saturated, okay, there is no systematic name, and for without nitrogen it is ane. And for 7 member, that is hepta. You can remember it is hepta EP. Okay, hepta. You can take this EP. So it is epine, epine. Okay, no name for this one with nitrogen, and for without nitrogen is epine. And for octa, OC, you can take octa. That is OC, octa. You can take the name OC. Okay, octa. That is oxime. Okay, no name given for unsaturated without nitrogen, and for saturated with nitrogen is same without E, and for this one is okay. So in every case, the saturated case, the without nitrogen is ANE is repeated, and for with nitrogen, dine, etidine, olidine, etc. is being repeated. Okay. So actually, I told you this suffix or the stem, the name ending, gives the idea of the size of the ring as well as the saturation or unsaturation present in the ring. So let us do some of the example in naming single 3 to 10 membered heterocycles. Okay, you can see here, first example, you can see the heteroatom is aza, nitrogen. So the name given is aza. Okay, so what you can do is you can write it is aza, okay, and the suffix, okay, because it is prefix plus stem, prefix plus suffix, so aza, and it is 3 membered unsaturated, it is arine. Okay, it is arine. So the name will be, you can add this one, so it is azirine, aza plus arine, azirine. You can replace a with the suffix azirine. And the next one, it is a saturated analog. Again, it is with nitrogen, so the prefix for nitrogen is again aza, and the suffix, that is it is saturated analog, it is iridine. So the name will be aziridine. So you can replace a with the iridine, so it will be aziridine. Okay. The next one, you can see here, it is oxygen, so it is oxa plus it is without nitrogen, saturated without nitrogen is arine, ane, and with ane is arine, so you can replace a by arine, so it is oxirane. It is oxirane. Coming to this one, it is one heteroatom is oxygen, it is oxa, the prefix is oxa. Nitrogen is aza, and it is with nitrogen, saturated with nitrogen is iridyne, it is iridyne. So the name is oxaciridine, it is oxa. You can add this one, and a you can add this one, it is oxaza plus ridine, it is oxaciridine. The name will be oxaciridine. For the time being, I am not explaining the number system. For the time being, I am just explaining what is a prefix and what is suffix, how they are combined to get the systematic nomenclature. Okay, if you take the unsaturated form membered, okay, you can see it is aza, it is aza plus form membered unsaturated is eat. Okay, tetra is eat, so the name will be azete. Aza plus eat can replace a by et, so the name will be azete. If you take similarly, if you take the saturated, that is aza plus etidine, because it is saturated with nitrogen, name will be you can replace a by etidine, it will be acetidine. Okay, this will be the name. You can write some more example. If you take sulfur, okay, form membered with sulfur, it is thia. Plus ethane, okay, without nitrogen, ethane, so name will be thietane. If you take oxa plus ethane, it is oxa plus ethane, so the name will be oxetane. And 5 membered with phosphorus, it is phosphor, the prefix is phosphor. And for suffix is ol, it is 5 membered, that is ol. Okay, it is phosphol, it will be phosphol. If you take the 7 membered, again aza plus hepta, it is epine, it will be azepine. Again take the 7 membered oxa epine, okay, that is saturated, so unsaturated without nitrogen, it is oxypene. A is replaced by epine, oxypene. Again sulfur, that is thia plus unsaturated without nitrogen is epine, so it is thiopene, like this one. So this is the way you can mix prefix as well as suffix to get the name of a one single membered heterocyclic compounds. Okay, suppose in the same case, if there are different heteroatoms are present, okay, you need to number the position of the heteroatom also. For example, next point is presence of identical heteroatom. If 2 or more same heteroatoms are present in the ring, the prefixes like you can add prefixes like di, tri, tetra, etc. are being used as the prefixes before the prefix of the heteroatom. For example, you can take this one. It is aza plus oily azole. Okay, it is actually so you can number it. It is azole, but it is 1, 2. Actually, a number is from here because 1. This I will tell you what is the reason that I will tell you while writing the indicated hydrogen 1, 2, 3, 4 like this one. Okay. So this will be 1, 2, 4. Tri, I am adding tri. Okay, then it is name is azole, triazole. Name is azole, aza plus oily, and but we are adding a suffix tri before the azole. Okay, that is triazole. So this one is azine, aza plus I. Okay, it is azine. Okay, Actually, it is pyrimidine, but I can write it as azine. It is di plus azine, diazine. I am adding the suffix di before the I am adding the prefix di before the uh, name of the heteroatom. So it is 1, 2, 3. So it is 1,3 diazine. 1,3 diazine. Actually, the common name is accepted for this compound, that is pyrimidine. Pyrimidine. Okay. So pyrimidine with numbering, I can say it is 1,3 diazine. Actually, the compound is azine, diazine. So it is 1,3 diazine. So this is azine. Again, it is azine. Aza plus ine. Okay, it is aza plus ine, azine. But you can number it 1, 1, 2, 3, 4, 5, 6, like that. So it is 1, 3, 5. It is 1, 3, 5 diazine. Okay, it is 1, 3, 5 diazine. 135 diazine, like this one. Okay. So next point, I can say that if different heteroatoms are present, I told you if the same heteroatoms are present, you are using di, tri, tetra, etc. But if different heteroatoms are present, okay, then the prefix of heteroatom are combined in the order of preference. Okay, so there is a order of preference. So first preference is given to the oxygen. Okay, oxygen, sulfur, selenium, tellurium, nitrogen, phosphorus, arsenic, antimony, bismuth, like that it goes on. Okay, so the order is like this one: O, S, N. Okay, oxygen is going to be most important, then for sulfur, then nitrogen. In the case of numbering, the order is OSN. You have to remember this one. It is OSN. OSN. So in the case of numbering, first number should be given to this, not to nitrogen, but it should be numbering also or naming also. You have to write not aza plus. First you have to write the uh, thia. So not it is aza plus thia. It is because the first preference is sulfur, so it is thia plus aza plus OLE. It is 1,3. So it is 1,3 thiazole. Thiazole. You cannot write aza plus thia plus aza thiazole. Okay, it is thia aza plus sol. It is 1,3 thiazole. So here it is first preference should be given to oxygen. So while writing this one before nitrogen, it should be oxa plus there are two nitrogen, so I am writing diaza. It is 5 member, that is old. So it is 1, 2, sorry, 1,3,4 oxadiazole. The name will be oxadiazole because oxygen should get the preference compared to the nitrogen. In the case of sulfur and nitrogen, you can say that sulfur comes the first preference. So it will be thia, plus aza plus ine. So it will be thiazine. It will be thiazine. The name will be thiazine. Okay. So let us write the next one is numbering. Okay. Next rule is numbering. If one heteroatom is present, okay, the heteroatom is given the position 1, and it is proceeded to get the lowest possible number to the substitution if present. For example, pyridine, it is the first number is azine. 1 is for the nitrogen, and here you can see here it is 1 is for nitrogen. Again it is pyridine. It is 1, it is 2, it is 3, 4, 5. So name will be the name is used as pyridine, and it is 2,5-dimethyl pyridine. The name of the heterocyclic compound is pyridine. So no need to write the one azine. It is 2,5-dimethyl pyridine. Okay. Suppose again in the case of numbering, if there are two or more identical heteroatom, okay, if two or more identical heteroatom is present, so the heteroatom are assigned to get the lowest possible set of numbers. For example, in this case, okay, I can write two way. One, I can write it is 1, 2, 3, or other way I can write it as if I start from here, I can start, if I start from here 1, 2, 3, 4. So this 1, 4. So there are two sets. One is 1, 4, 1, 4. Okay, that is wrong because we have 1, 3. So it is 1, 3 is the lowest set. 1, 3 diazole. It is 1, 3 diaza plus oily diazole. So this is the right way of nomenclature. But we know that this compound is imidazole. The common name is accepted in this compound, so it is imidazole. But the numbering will be like this one. Okay, this compound is known with its common or trivial nomenclature system. If you come to this one, if you come to this one, that is 1. Can write it is 1, 2, 3, 4. Okay, so the name is 1, 2, 4 triazine. Okay, but if you start from here, it will be 1, 2, 3, 4. So 1, 3, 4 is wrong. It is wrong because this is 1, 2, 4 is the lowest set of number than 1, 3, 4. So it's similar here in the case of imidazole. 1, 3 is the lowest set than the 1, 4. So this is wrong. So that is the case of numbering with identical heteroatom. So again, in the case of numbering, if two or more different heteroatoms are present, again, if different heteroatoms are present, the first number should be given to the, again, that is the order of preference, that is OSN, oxygen, sulfur, and nitrogen. So here 1 should be given to the oxygen. It is 1, 2, and 3. So the name will be 1, 3. It is 1, 3 oxa plus aza plus oily, that is oxazole. 1, 3 oxazole. Okay, here the one again, first preference is oxygen. I told you the order of preference is oxygen, sulfur, and OSN. So this is 1, it is 2. So it is 1, 2 oxa thia plus olane, thiolane. Oxa thiolane. It is oxa plus, can remove A, it is oxa thiolane. It is 1, 2 oxa thiolane. This oxathiolane. So in the case of this one, the first preference is for the sulfur. It is 1, because if you go in this way, it is 1, 3, 5. It will be 1, 3, 5. So instead of 1, 3, 5, you can go like this one to get the lowest set. It is 1, 2, 3, 4. So it is 1, 2, 4. So the lowest set is 1, 2, 4 thia diazole. 1, 2, 4 thia diazole. Okay. And the most important thing is the indicated hydrogen. If there is a saturated atom, so for example, in a heterocyclic system, a maximum number of double bond contains a saturated atom. Okay, you can see here maximum number of double bonds, okay, is incorporated with a saturated atom. Its position is given the lowest possible number, and it is indicated as italic capital H. So this indicated hydrogen, so this is the indicated hydrogen. Okay, this saturated atom bonded with different unsaturation, a multiple bond, is indicated as a italic capital H. Okay, so this italic capital H should place before the name of the heterocyclic ring system. So for example, here it is 1. So this will be given the number 1. So it is 1. Sorry, it is 1. It is 2, because you cannot go 1, 2 like this one, because there is a indicated hydrogen over here. So the 2 will be not here, 2 will be here, 2, 3 like this one. So the name is it is pyrrole. The name is it is pyrrole. Okay, it is pyrrole. But before that one, you have to indicate this indicator hydrogen, that is 2H pyrrole. Okay. Similarly, if you come to this one, you can say there is a saturated atom over here. Okay. So it is, but you know that the order of preference is oxygen, sulfur, and nitrogen. So the first number should be for 1 for sulfur, 2, 3, then for the indicated hydrogen. So the name will be it is 4H italics, 4H. It is 1 for thiazine, thia plus aza plus ine, thiazine, 1 for thiazine. If you take this one, the next example, if you take this example, you can see here the indicator hydrogen is over here. Okay, so the first number will be obviously for sulfur. Okay, but you can't go 2, 3, 4 like this one, because you have to go 2 here, because there is a indicator hydrogen 2, 3, 4. Cannot go in this way. Okay, so if you go this one, this indicator hydrogen will get the highest number, that is 6. So the name is 2H 1 for thiazine, thia plus asa plus ine. So again, in this case, you can see that the indicator hydrogen is present over here. Okay. So the order of preference, I told you, it is OSN. It is OSN. So first number will be for oxygen. Second, if you go 2, 3, 4, 5, this will be 5. So the set will be 1, 5. Okay. But if you go this one 1, 2, 3, the set will be 1, 3. So the first importance should be given to the heteroatom. So it will be 1, 2, 3, 4, 5, 6. So the name is 6H. The name will be 6H 1, 3 oxa plus asa oxazine, oxa plus asa plus ine, oxazine. Okay. And one more thing, if for the case of this saturated atom, for the indicator hydrogen, if the heterocyclic ring system in which a carbon atom is associated with a carbonyl group, if it is associated with a carbonyl group, okay, then the indicator hydrogen is usually cited as an italic H in the bracket, in the parenthesis after the locand of the additional feature. Okay, for example, if you take the first case, okay, first example, you can see it is pyridine. Okay, the compound is pyridine. Okay, and there is a carbonyl group, so it is pyridinone. It is pyridinone. Okay, and you can see that the additional feature is ONE. Okay, carbonyl group, and the indicator hydrogen. Okay, this one, the indicator hydrogen is located after the additional feature, that is, the name will be pyridine. Okay, then after this one, you can write the position of the indicator hydrogen in parenthesis 2, because this is it is pyridine 2 on, it is pyridine 2 on, so 2, after 2 you can write the position, that is 1. Okay, it's 2, 1 H ONE. So pyridine 2 on will be pyridine 2, 1H ONE. Similarly, this one, if you write the compound is it is pyrazine. Okay, 1,4-diazine is actually it is pyrazine. Okay, the name of the compound is pyrazine, that is 1,4-diazine. 1,4-diazine. The common name is pyrazine. So the name of the compound will be pyrazine. Pyrazine 2-on. Pyrazine on. But you can see that the indicator hydrogen is at the position 3. That is 1, 2, 3, 4. So you can go 1, 2, 3, 4 in this way also. But if you go in this way, we'll be missing the additional feature, carbonyl feature, as well as the indicator hydrogen. So the best way is to go 1, 2, 3, 4 in this way, anti-clockwise. Okay. So the name will be now is pyrazine. Pyrazine. Okay. After the additional feature, the position of the additional feature, that is 2, we have to place the indicated hydrogen 3H ONE, 3H ONE, like this one. Okay. So that is the case of nomenclature. And I will give some examples. You can see here. You can write some of the examples. It is first one is you can see here 3-membered. Okay, 3-membered. It will be thia. It will be thia plus irene. Thia plus irene. Thyrane. 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 It is oxa, because oxygen will be the preference wise. Oxygen will be coming first, plus aza, then plus aza, and 3-membered unsaturated. It is irine. It is, if you write this one, it is with position 1, 2, oxazirine, oxazirine, oxazirine. And it will be oxazirine. And this 5-membered, it is oxa. Okay, so first will be the numbering should be given to the oxygen, OSN 1. Okay, 2, 3, 4. It is so it will be oxa plus aza plus INE. 6-membered, it's as NE. So you can write with the indicator hydrogen, because there is an indicator hydrogen at the position 4. So it will be 4H, 1, 4 oxazine. Okay, this will be name. And in this case, okay, you can write OSN. So first number it will be 1, 2, 3. So it is thia plus aza, thia plus aza plus INE. So it is thiazine. So you can write the indicator hydrogen is in the second position. Okay, it is in the second position, H. So it will be 2H, 1, 3, 1, 3, thiazine, thia plus aza plus thiazine. If you take a compound with phosphorus and arsenic, okay, so the preference wise, first will be phosphorus. So the prefix is phosphor plus arsa, phosphor plus arsa, plus it is without nitrogen is olidine. Okay. Sorry, not olidine. It will be without nitrogen, ol. Okay, it is unsaturated. That is ol. So this will be, you can number it like is 1, 2, 3, 4. Okay, and you can see that in the second position there is a indicator hydrogen. So the name will be 2H. It will be 2H, 1, 2, 4. 1, 2, 4. Phosphor diarsa. Arsa, it is diarsa. plus oily diazole. It will be 2H 1,2,4 phosphodiazole. Phosphodiazole. Okay. If you take this compound, okay, it is this one, sulfur OSN. So sulfur 1, 2, and 3. You can see that uh, it is thia plus aza plus olidine. So the name will be olidine. It is 1,3,1,3 thiazolidine. Okay. If you take the cell number, okay, that is epine. Okay, aza plus phosphor plus epine, and you can see here this position. Okay, at this position there is a indicator hydrogen. So you can write number 1, 2, 3, 4, 5, and 6. So name will be 6H 1, 3, 5 diaza phosphor plus epine phosphor plus epine phosphipine 6H135 diaza phosphipine. Okay, so that will be like this one. If you write this one, it is 1 substitution will be in the lowest number. You can't go 1, 2, 3, 4. So this is the order of preference. So it will be 2-methyl. The name will be 2-methyl. 2-methyl. Suppose, okay, if there is a double bond over here, 2-methyl. This will be the indicator hydrogen. So 1, 2, 3, 4. Okay, you cannot go 1, 2, 3 like this one, because substitution should get the importance than the indicator hydrogen. So you cannot go 1, 2, 3 like this one. So the substituent should get the lowest number. So it is 2-methyl 4H oxa plus ete oxide will be oxide. Okay. And next is trivial system. Okay, so you can write that trivial system does not convey any structural information, but they are still widely used. Okay, actually these trivial or semi-trivial names are given on the basis of the characteristic properties from the source which they are obtained. Okay, however, these names are recognized by the IUPAC, and these names are retained in fusion nomenclature system also. Okay, for example, first one is pyrrole. It is pyrrole. Name is pyrrole. It is furan, and it is saturated analog is tetrahydrofuran THF, a well-known solvent THF tetrahydrofuran. Okay, pyrrole. The saturated analog is pyrrolidine. It is pyrrolidine. So there is thiophene. It is thiophene, and it is selenophene. Selenophene. It is selenophene. It is pyrazole. 1, 2 azole. It is pyrazole. It is pyrazole. And 1, 3 analog is imidazole. 1, 3 is imidazole. Okay. And next one you can write. It is isoxazole. Okay, not the oxazole. It is half dihydro. It is, so it is isoxazole. It is pyridine. It is saturated analog is piperidine. 1, 2 diazine is pyridazine. It is pyridazine. 1, 2 is pyridazine. 1, 3 is pyrimidine. 1, 3 analog is pyrimidine. And 1, 4 is the pyrazine. 1, 4 is pyrazine. Okay, you remember pyridazine is 1, 2. 1, 3 is pyrimidine. 1, 4 is pyrazine. Its saturated analog is piperazine. piperazine, and this is the well-known compound is pyran. Okay, this compound is pyran. This is morpholine. It is morpholine. Okay, and this is indole. This compound is indole. Benzene fused with the pyrrole is indole. Then it is isoindole because it is positioned in the second. So it is isoindole. Okay, and you can see it is benzene fused with the pyrrole. It is indazole. It is benzimidazole. Benzene fused with the imidazole is benzimidazole. Okay, benzene fused with the furan, benzofuran, benzene, benzofuran, and it is isobenzofuran. You can see the position in this. So benzofuran. Okay, you can see it is thiazole. Benzene fused with thiazole is benzothiazole. So these are the certain common names accepted by the IUPAC. And another important one is quinoline. It is isoquinoline. It is isoquinoline. It is purine. Purine is important. Okay, you can see that the numbering is there is a exception in the case of numbering. Actually, the numbering will be like this: so 1, 2, 3, 4, 5, 6, 7, like this one. So these are the certain names which are accepted by the IUPAC. Okay. And last, we shall discuss certain replacement nomenclature system. So heterocyclic compounds are considered to be derived from the carbocyclic compounds by the replacement one or more carbon atoms by the heteroatom. So this forms the basis of the replacement nomenclature system. So if you take this cyclopropane, so this will be oxa plus cyclopropane. So it is oxa cyclopropane. It is cyclobutane. So oxygen is replaced. So it is oxa cyclobutane. Okay. Next is cyclo pentane. That is sulfur is replacing a carbon. So it is thiacyclopentane. It is 1 is right 1, 2, 3, 4, 5. It is 2, 5 is pentadiene. So it is oxa cyclopenta 2, 5 diene. It is benzene. Okay, so benzene, or I can write it is azabenzene. Normally it is known as azabenzene. That is pyridine, azabenzene. Okay, this one you can write the first one is 1, 2, 3, 4, 5, 6. So the name will be 1 thia, 4 aza, cyclohexadiene, the double bond is on the 2, 5 diene. The name will be like this one. So this compound is it is pyrimidine. The name is 1, 2, 3. So it is 1, 3 diazabenzene. 1, 3 diazabenzene. Okay. So this is replacement nomenclature, and in the next class we shall discuss the very important fusion nomenclature system. Okay. Thank you.